right. In this video, I'm going to be going over page 17 of the notes packet. So this is where we're taking I, which in the last one we learned was equal to the square root of -1. And we want to take it to different powers. So if we think about I squared, well, that's the square root of -1 times the square root of -1. The square root of -1 times the square root of -1. That's just -1, right? We know the square root of anything times itself is just that radicand, like the square root of 2 times the square root of 2 is just 2. For I cubed, well, we can write that I squared times I, which means we can do -1 times I. So this is just -I. And then I to the fourth would be that, -I, times another I. We think about negative square root of 1 times, or square root of -1 times the square root of -1. So remember, I is the square root of -1, so both of these would be negative. Well, we know I squared. We know that when we multiply these together, we get -1. But now we have another negative on the outside, so this becomes +1. And if we multiply by I to the fifth, now we take I to the fourth, multiply by another I, and we just get I. Well, I to the sixth, well, that would be just what we did when we went from I to I squared, right? Now we have I to the sixth, which is equal to I to the fifth, which is equal to I to the fifth times I. So that's just equal to I times I, which is just -1. And if we go all the way up to the 11th, you can see that the I to the fourth is going to be 1, I to the eighth is going to be 1, I to the 12th is going to be 1. And so 1 before I to the 12th is I to the 11th. We know that's going to be -I. So the pattern here is just that it goes in order, right? So it repeats, going I, -1, -I, +1, and so on and so on. So how do we use this to find higher powers of I? Well, we want to use that pattern, and how we're going to do that is we're going to figure out what the remainder is when we divide by 4. So remember the pattern here. I'm actually going to write this a little bit more specifically. I'm going to say I to the first is I squared is -1, I cubed is -I to the fourth is 1. And it continues like that. So it goes I, -1, -I, 1, as you go to the 5th, 6th, 7th, on and on power. So we're going to use that to find I to the 40th. So for I to the 40th, we want to figure out how many times do we go through that cycle. Well, if you think about I to the 40th, we do the whole cycle 10 times. So if I to the fourth is equal to 1, so is I to the 8th, so is I to the 12th, so is I to the 16th, on and on. So this would be 1. So when we divide 40 by 4, we get a remainder of 0. And that means that it's equal to I to the fourth, which is 1. Which makes sense too, because you could also think about the remainder, yeah. So with I to the 82nd, when we divide it by 4, we get a remainder of 2. And that means that we're in the second part of the cycle, right? So the first part of the cycle is I. The second part of the cycle is -1, meaning that I to the 82nd would be -1. So if the remainder is 1, so remainder equals 1, then the answer is I, when you divide the power by 4. If the remainder is 2, then it's negative 1. If the remainder is 3, then it's negative I. And if the remainder is 4, then it is just 1. Sorry, you wouldn't have a remainder of 4. If the remainder is 0, meaning that it's a power of 4, then your answer is just 1. Okay, so if we look at this, if we divide 18 by 4, we're going to get 16 and a remainder of 2, which means that we are at negative 1. If you do r to the 109th power, you're going to get 108 with a remainder of 1, meaning that this is just I. If you go to 437, you're also going to have a remainder of 1, meaning that it is just I. If you go to 65, you're going to have a remainder of 1, meaning that it is just I. All right.